Welcome to Algebra 1, Lesson 1.6. Today we're going to talk about adding and subtracting polynomials. And it's pretty simple. It's just like combining like terms, which you may already know about. So the first thing we need to talk about is what are like terms? Well, a like term is going to have to meet two qualifications. First, you have to have the exact same letter used and the exact same exponent for the variable. So let's look at an example here. It says 3xy squared plus 2x minus 5y squared minus 8x plus 9y squared plus 2xy squared. That's a lot of terms. Wow. Remember, each one of these separated by a plus or a minus is a term. And we want to combine the like terms. So we want something that has the exact same letter or letters and the exact same exponents. So I'm going to start with the one that's a little easy. I'm going to look at anything that has an x to the power of 1. Okay, so I see right here a positive 2x, and I see right here a negative 8x. This term and this term, even though they have an x that's to the implied power of 1, does not count because it also has a variable y. So it is not considered the exact same because it has x and y in it. Okay, so it does not meet that first qualification of having the exact same letter or letters variable. Okay, so we only have the two here. Now, in order to combine these like terms, all we have to do is add or combine the coefficients. That's the number before the variable together. So a positive 2 and a negative 8. When we put those together, we're basically going to be adding them. 2 plus a negative 8. Okay, when you have different signs, a positive 2 and a negative 8, different signs, you're going to find the difference. So 8 minus 2, and that's 6. And then your answer takes on, in your original numbers, it's going to take on the value, positive or negative, of the larger number. Since negative 8 is larger than 2, our answer is a negative 6. Now, the easiest thing to do is just to plug it into your calculator, because sometimes it's very easy to get your negatives mixed up. One of the most common problems, not problems, but mistakes I see people making is adding a positive and a negative together. So if you just use your calculator, you can eliminate all the errors, attention to detail errors that happen when you try to do it in your head. It's good to do it in your head and then verify it with a calculator. So we've combined positive 2 and negative 8 to make a negative 6. And then all you do is you simply write the variable exactly as it was, no change right there. It's like saying, if I had 2 apples and you took away 8 apples, how many would I have? Well, I'd be missing 6 apples. Okay, nothing changed with the apples or the variables in this case. All right, now I cross them out when I'm done with it, so I know to move on to the next variable. Now, the next one I'm going to look at, I like doing the singular variables before I get into the duplicate variables. So I'm going to go on to this y here. I've got a negative 5y squared. Here's a y squared as well, same letter, same exponent. So this works. Again, it cannot be done with this one because even though there's a y squared, there's an x with it as well. That is not considered a like term because the letters do not match. This is an xy, okay? Or an xy to this second power, or y squared. So let's go ahead and combine this, a positive 9 and a negative 9. Positive 9, I'm sorry, and a negative 5. Okay, well, when we combine these, that's easy enough. We can do 9 minus 5, right? and we're going to get a positive 4. See, different signs, you find the difference, and your answer carries the sign for the larger number. The larger number is positive, our answer is positive. So we're going to do plus 4, and this was, remember, y squared. So we're just going to write it just like that and cross this out. Oops, I crossed out the wrong one. Let's cross out this one. All right, now that leaves us with any term that has x, y squared in it. So I've got my first one, and this one is x, y squared as well. Both the x's have the same exponents and the y's have the same exponents. So these are considered like terms. This is a positive 3 and a positive 2. So in order to combine them, we just add 3 plus 2, and that's going to give us a positive 5. Don't forget to write the variables x, y squared. So this is combining like terms. Okay, so that's also known as simplifying the polynomial. Now, if you're taking notes, I have it written here in better handwriting for you. So if you like that, you can write that down. Now let's see how this works when we add two polynomials together, because really that's what adding polynomials is about. Essentially, we have one polynomial here inside the parentheses and a second polynomial here inside of these parentheses. But when we're adding polynomials, we don't need to do anything with these parentheses because we can't combine anything inside of this. We can't simplify what's inside these parentheses. So we can just go ahead and write it exactly like it is. Now keep in mind, this is when you're adding two polynomials. Adding, that's the key. Subtraction, we'll see there's some extra steps. So now that I've gone ahead and written that, I need to find my like terms. I'm going to start with this first term here. It is x squared. So let's look and see if we find any more x squareds. Here's an x squared. I see some other x's, but since they're not squared, I can't combine them. Here I've got a positive 2 and a positive 3. So adding those together, I get 5x squared. Okay, now I'm going to go to this term. And I have just a simple x. I remember seeing one of those over here. Here it is. And this is a negative 2 and a positive 6. So a positive 6 and a negative 2 is going to make a positive 4. So plus 4x. Again, if you do your math in your head or on paper, you can always please check it with a calculator just to be sure. And finally, the last term we're going to combine are what we call the constants because they have no variables. That makes them like terms as well because their variables are the same. They don't, whatever the variable is, let's say it's x, it's to the power of 0. It doesn't exist there, okay? So a positive 5 and a negative 1, 5, negative 1 is a positive 4. So here is our answer to 2x squared plus 6x plus 5 plus 3x squared minus 2x minus 1. It's 5x squared plus 4x plus 4. Now I've got that typed up for you so you can see it in some better handwriting. All right, now let's get to subtraction. You notice this time we've got a subtraction sign. Well, you should remember from when we learned about distribution that if you have a subtraction sign before some parentheses, it's really like having a negative 1 in front of these parentheses. And that 1 is touching the parentheses, so that's a times. So we have to distribute this negative into the parentheses. You have to apply the negative to each and every term. We have to distribute it, okay? So the first thing you have to do is rewrite, oops, that's supposed to be a squared. I'll have to go back and fix that. At 5y squared plus 2xy minus 9, and now I'm gonna do this first. I'm gonna apply this negative to my first term, negative 2y squared. Now I'm going to apply this negative to my second term. So if it's a positive 2xy, and I'm multiplying it by, remember, an implied -1. That makes it a negative 2xy. So the number and the variables don't change when you multiply it by a -1. The only thing that's going to change is the sign. It went switched from a positive to a negative. So now I need to apply this negative to a -3. Negative times a negative becomes a +3. If you notice, all that's happened is I've put and changed the signs of each one of these. This was a positive 2y squared. It became a negative 2y squared. This was a positive 2xy. It became a negative 2xy. This was a -3. It became a +3. That's the first step. And the only difference between addition and subtraction of polynomials, you have to remember with this negative, it's extremely, extremely important. Now, before moving on, my little error here of this 2 made me want to remind you that sometimes on written work in the computer, you may see something like 5y, and then it has this special little kind of bottomless triangle here, okay? This is called a caret, and you can find it above the number 6 on the top of your keyboard. So 5y caret 2 is essentially 5y to the power of 2, or 5y squared. This is the way, if you don't have any kind of special formatting to be able to get this superscript up here, it's the number that hangs up in the air. Superscript. If the program you're working in doesn't allow superscript, this is the way that you write it. So sometimes in electronic math books or other electronic devices such as a math quiz online, things like that, you may see it written like this. Please know that that's a square or a power, because it's not always a 2, right? It could be a 5. So now what we're going to do is look for our like terms. I'm going to start here with 5y squared. Look, here's another y squared, 2y squared. Just double check, make sure there's no other y squared. There's not. So I've got a positive y and a positive 5 and a -2. So 5 and -2 make 3. So I've got 3y squared. Cross those out. All right, next one is going to be a positive 2xy, and here I have a negative 2xy. So 2 minus 2 is 0. And when we have 0 times x times y, what does that give us? That just gives us a simple 0. So when you have a coefficient of 0, your term actually disappears. So it's just like when you cancel out in algebra. There's nothing for us to do there. Then we've got our constants, -9 and +3, okay? Different signs, we're gonna find the difference. 9 minus 3 is 6. Our answer is going to take on the sign of the larger number. 9 is larger than 3, so it's gonna be a -6. So 3y squared minus 6. And that is our final answer when we subtract these two polynomials. All right, so now I want you to go ahead and pause the video and work these out yourself, and then unpause it and I'll show you, we can work them out together if you get stuck. All right, see you in a minute. Welcome back. All right, so we're gonna go ahead and just get started. 2x minus 5y plus 2 plus 5x plus 6y minus 7. So we start with addition of polynomials, just dropping the parentheses. That's all we have to do. Then I'm going to look for my x's. I like to underline it so my eye is easily drawn there so I can see what I'm working with. I've got my 2x and my 5x. That's going to make 7x, right? All right. Cross those out. Now I've got my -5y and positive 6y. Positive 6 and -5 make a +1. We do not need to write a 1 as a coefficient. It is understood or implied. So let's go ahead and cross those out. And we have left our constants, a +2 and -7. Combining those, different signs, negative and positive, we take the difference. 7 minus 2 is 5. And our larger sign in this case is a negative. It takes the answer, so negative 5. 7x plus y minus 5. Let's make sure I got, oops, go back there. Now the next one. Now the first thing we have to do, remember, is we're going to distribute this negative sign to each term of this second polynomial. And what that simply means is we have to change the signs of every term in here. So I'm going to write the first polynomial exactly as it is without the parentheses. 3x squared, so 3, minus 4x minus 2. Now, I'm going to go ahead and apply this to the first one. So a negative with a negative becomes a positive x cubed. Apply it to the second one. A negative with a negative becomes a positive 4x. And then apply it to the third one. A positive with a negative becomes a negative 7. All right, so let's start with the squareds. Uh-oh, I don't see any other squareds, but I did notice here, x to the third, I should have kept that positive in there. That's actually bigger than the squared. And since I want to keep this in standard form, I'm going to start with that one because it's my biggest one. So there were no other x cubed, so I'm going to just start with that. There were no other x squared, so that's a positive 3x squared. Go ahead and cross that out. I see an x to the power of 1 here and here. Now that's a positive 4 and a negative 4, which make 0. So they cancel out and I don't have to write them down. Okay, now my constants, negative 7 and negative 2, make a negative 9. So I've got x cubed plus 3x squared minus 9. All right, last one here. Go ahead on this first polynomial and drop the parentheses. Write it exactly the same, 3x cubed minus 2xy. Second polynomial, I have to distribute the negative sign. So this is a positive with a negative, becomes a negative x cubed. A negative with a negative becomes a positive 4xy squared. And a negative with a negative becomes a positive y cubed. Now let's actually, before I get started, let's look at what the largest degree here is. I see a 2 and a 1. That's a third degree, third degree, third degree, second degree, and third degree. So I've got a lot of third degree things here. I'm going to go ahead and start with 4xy squared. 4xy squared is the term I'm going to start with. Let's see if there's any other xy squareds. Okay, well, I see an xy, but it's not xy squared. So this one's all by itself. So I'm just going to go ahead and write it here, 4xy squared. And because it's positive, I don't need to put anything in the front of it. You can go ahead and cross it out. Now, x comes before y. So I'm going to go ahead and do that one next. I've got some x cubes here and here. So when I look at that, the coefficient of this one is a positive 3. The coefficient of this one is a negative 1. Remember, if you don't see a coefficient, that means it's an implied number 1. So 3x cubed minus, and then a negative 1x cubed. So 3 and negative 1 make a positive 2. And remember, our variable is x cubed. Go ahead and cross those out because I'm done with them. Now let me move on to my y here. There's only one y, so I'm just going to write it exactly as it is. And my last term that I have over there, negative 2xy, is a loner as well, negative 2xy. And I'm done. Hopefully you got all of those correct. I'm sure you did. Make sure when you're taking notes, you have all of your examples written down so that you can look back at them later. Now, adding and subtracting polynomial practice, you know, you're going to have some word problems. That's just the way School works. So let's get to it. The length of a rectangle is 3 more than 4 times the width. That's a lot of words. What's that mean in math? Well, we know we're looking for the length of a rectangle, right? It says the length of the rectangle is. The length of the rectangle is 3 more than. 3 more than. 3 more than something. I know I'm going to add 3 to it. Okay, I've got to add 3, but I want to know what I'm adding 3 to. 4 times the width. Okay, I'm going to put a 4 and a W, and then I can't forget I had to come back to this 3 more than. So plus 3. Let's check this out and see if this works. The length of a rectangle is 3 more than 4 times the width. Okay, so I think that's going to be a pretty good math sentence for us. I wanted to go ahead and write it without that rectangle. Length equals 4 times the width plus 3. The length of the rectangle is 3 more than 4 times the width. Now it says write an expression to represent the perimeter. Oh my gracious, so I didn't even answer the question. Well, at least I know what the length is. So I have to remember the perimeter is adding up all sides of a polygon, right? So our polygon has 4 sides. With a rectangle, we know that the length, it has 2 lengths that are exactly the same and 2 widths that are exactly the same. So if this is our length and we know that there's 2 of them that are exactly the same, well, we can write that 4W plus 3, that's 1 length, right? Plus a second length, okay, plus 4W plus 3. Okay, well, that represents the length and the length of the rectangle, but what about the width and the width? Well, we aren't told what the width is, so we can just add it just like a W, just like that. And it equals P for perimeter. Well, look at that. I'm adding to polynomials here, right? My lengths were represented with polynomials. So since this is addition, I can just drop my parentheses. 4W plus 3 plus 4W plus 3 plus W plus W equals P, or perimeter. All right, now I can combine like terms. I've got a W here, that's a 3, that's a constant. I've got a W here, that's a constant. I've got a W here and a W here. 4 plus 4 is 8, plus 1 is 9, plus 1 is 10. 10W. All right, now let's add the constants I saw. Plus 3 and a plus 3. So I've got plus 6. Okay, so my answer is 10W plus 6 equals P. Or it's actually better written as P equals. Perimeter equals 10W plus 6. All right, so that's your final answer here. Now, what's the perimeter of the figure below? This is a triangle, but I'm sure you can figure it out. It's actually very similar to the one we just did. You're going to just add up all 3 sides, and then you're going to have to simplify it or combine the like terms. So I want you to go ahead and pause the video, figure this out on your own, and unpause it when you're ready to go over the solution. All right, welcome back. So to find the perimeter, we just have to add these sides together. 3x plus 2 is the first side. I'm going to cross it out because I know I used it. Plus x minus 8, that's side 2. And then plus the third side, 2x minus 7. So I've got side 1, side 2, and side 3. And I just randomly picked which side. It doesn't matter the order. Remember, when you're adding, the order is not important. Okay, so perimeter is going to equal side 1 plus side 2 plus side 3. Well, remember, since this is plus for all of our polynomials, all we have to do is, in our first step, just drop our parentheses. 3x plus 2 plus x minus 8 plus 2x minus 7. Now we need to find some like terms. I've got an x here, an x here, and an x here. 3 plus 1 plus 2, 4, 5, 6. So that's 6x, okay? What else have I got? The rest are all constants, a positive 2, negative 8, and negative 7. All right, I'm going to start with the negatives. I'm going to put them together. Negative 8 and negative 7 make a negative 15 when I add those together, okay? Negative 15, and then a positive 2. I have different signs, so I need to take the difference. 13, 15 minus 2 is 13. The larger number gets, the answer is going to get that sign. So it's a negative 13. I want you to check that in your calculator. Negative 7 plus a negative 8 plus 2. Make sure you get a negative 13 there. So that is your final answer. And that's it for our lesson on adding and subtracting polynomials. We'll be back with multiplying polynomials in just a moment.